Well, something recent, say over the past 60 million years or so, must have been happening on Europa to erase most of these craters from the surface. 16 years after Voyager, Galileo arrived to Jupiter. It spent 8 years studying both the gas giant and its moons. And Galileo's magnetometer picked up something interesting on Europa. Jupiter's magnetic poles, like Earth's, aren't aligned with its geographic poles. So as the planet rotates every 10 hours, the whole magnetic field wobbles. This changing field from Jupiter induces a magnetic field on Europa, and a relatively strong one at that. That means there must be an electrically conductive layer within Europa that reacts to Jupiter's field. And readings from Galileo indicate that it must be somewhere close to the surface, only tens of kilometers deep. So what kind of conductive layer? Well, Europa's white surface is almost entirely covered in a thick crust of water ice. These reddish-brown regions, when observed through a spectrometer, fit the description of a lot of things, like hydrated salts, sulfuric acid, or even bacteria. We need more data to be sure, but recent experiments at JPL found that sea salt, when bombarded with intense radiation, turns from white to this same brownish color found on Europa. So scientists suspect that there's a whole saltwater ocean inside Europa that could be 100 kilometers deep, meaning Europa would contain twice as much water as the whole of the Earth. And it must be driving geological activity that constantly smooths out and renews the surface of the moon. But the Jupiter system only gets about 4% of the sunlight we get here on Earth. So Europa's surface is constantly below negative 160 degrees Celsius, so you'd expect the whole ocean to be frozen solid. But there's a way to generate heat that doesn't rely on the sun. And I've got a little demo here to prove it. Europa's orbit around Jupiter isn't a perfect circle. This is because Io, Europa, and Ganymede are all in orbital resonance. Each time Ganymede completes one orbit, Europa completes 2, and Io 4. Because of that, Io tugs Europa inward on one side of the orbit, while Ganymede pulls it out on the other, making its orbit more eccentric. Now, Jupiter's pull is stronger on the closer side of the orbit than on the farther side. So Europa is constantly being stretched and squeezed, stretched and squeezed. And you can see how this rubber ball gets warmer as I squeeze it. Scientists believe that the friction caused by the tidal flexing of the entire moon can generate enough heat to keep the ocean liquid. This effect gets stronger the closer you get to Jupiter, which is why Io is so volcanically active. So you can see this ball is significantly hotter now. I held onto this ball at the same time to make sure it wasn't just the heat coming in from my hand. What sort of temperature of the ocean are we thinking?
So it depends on how salty it is. So melting temperature of ice, or maybe depressed by 10 degrees Celsius below that, if it's a very salty ocean, similar to cold oceans on Earth.
And how would the flexing differ if there's this big liquid ocean versus if there's no ocean there?
If there's no ocean, Europa should flex by only about 1 meter in amplitude. But if there's an ocean in there, then it flexes with an amplitude of 30 meters. So that's an enormous deflection, and that will come out pretty clearly in the gravity data. Another argument for how thick the ice shell is, we see these very strange features on the surface that are arcuate in shape, but like multiple arcs put together. We call them cycloids, and not something you'd expect to see on an icy moon.